Our next lesson is kind of an extension of completing the square, but it's also a revisit of the circles in the coordinate plane lesson. So first, we have to kind of remember what we already knew about circles, which was if we were given the center and the radius, we could come up with the standard form of that circle. So, just to refresh your memory, maybe one day, my pen will work. There we go. So x minus h quantity squared plus y minus k quantity squared equals radius squared. That is standard form for a circle. And today we're going to learn what's called Generalconic Form. We're going to realize that Generalconic Form is awful, and no one likes it. Alright, so they say use the information provided to write the Generalconic Form of the equation. Well, Generalconic Form is x squared, let's say plus bx plus y squared plus, say, py, plus c equals 0. Now the c could actually be moved to the other side of the equation, but the idea is it's what happens if you FOIL all those binomials out and you kind of collect all your like terms. So it's quite awful actually. The center and radius, remember these are your h and k's. So we're going to start in standard form, so x minus 4, and it's going to be one of these days again, guys, I can tell. Alright, x minus 4 squared, and then instead of saying y minus 0 squared, I'm just going to say y squared equals 5 squared, which is 25. So our first step is to FOIL this term out. So remember x minus 4 squared is x minus 4 times another x minus 4. So that becomes x squared minus 8x plus 16. And then we don't have to do any FOILing on the y parentheses, so that's excellent. So the only other thing I'm going to have you do is kind of rearrange some terms. I'm going to keep the x squared plus 8x kind of together. In some books, they'll put the x squared and the y squared together. It doesn't really matter. But the next thing I'm also going to do is I'm going to subtract this 16 over and combine it with this constant. I personally like when Generalconic Form has the constant on the right-hand side. It is up to you. I will accept either answer if I could subtract, so it equals 9. So I think you can tell by now that Generalconic Form, like, it doesn't really tell you anything. It's kind of awful, in fact.
Good morning, faculty students. Please stand for a moment.
And we're back. Alright, so this next one is similar in the sense where it gives you h and k and it gives you r. So we're going to start in standard form and then we're going to have to FOIL it out into Generalconic Form. So x minus h would end up being x plus 13 quantity squared plus y minus k quantity squared. And then instead of 4 squared, I'm going to write 16. So our first task is to FOIL this x plus 13 squared out. And then this time, we aren't so lucky, we do have to go ahead and FOIL out y minus 2 squared. All while remembering there's a plus sign between those terms, and there's still a 16 off to the other side of the equal sign. So x squared plus 13x plus, x plus 13 quantity squared is x squared. And then I'm going to skip a step. 13x plus another 13x is 26x's. And then 13 times 13 is 169. And for the blue FOILing problem over here, y squared minus 2y plus another minus 2y is minus 4y. And then negative 2 times negative 2 is positive 4. I still have that equals 16. Alright, so I'm not going to do a ton of rearranging here. What I am going to do, though, is this 169 and 4. I'm going to be subtracting them over here. So, let's see here. X squared plus 26x, that's gone, plus y squared minus 4y, and that's gone, equals, oh goodness, I should be able to do this, huh? Let's see, that's negative 173 plus 16, so 7, 6, 5, 1 negative, something didn't work out right there, guys, I don't know. I feel like that's okay. Negative 157 though. Alright, so once again, just to reiterate, what is Generalconic Form good for? For this point in Algebra 2, really nothing. I just want to show you how you can manipulate from standard form to Generalconic Form, because sometimes on standardized testing, they want the answer in Generalconic Form. So, That's not what our fun is going to be today, though. Our fun today is I'm going to start with something in this horrible Generalconic form, and we're going to use completing the square twice in order to write it into that usable form where I can identify the center and the radius. So your goal is, if you can write it in this form, standard form, then I can easily see who the center is and who the radius is, what the length of the radius is. So what we're going to do first is we're going to kind of group them together. I'm going to start by coloring these guys in red. So we're going to say x squared plus 4x, and we're going to complete the square on that quadratic component. Then I want you to write a plus sign down, and then if you have another color, I'm going to use green this time on y's. So y squared plus 6y, and once again, we're going to complete the square on that component. Now this original constant of minus 3, I'm going to go ahead and add that over to this side of the equation. But remember, we got to keep a balance here. So if I added this red blank over here on the left side of the equation, I have to also add it over here on the right side. And then same thing with this green blank. I have to add it to both sides of the equation to keep my balance. So completing the square on this red trinomial, remember the rule is you take half of your b term and then you square it. So 2 squared is 4, and that goes in both of the red blanks. And then same completing the square formula here for the y's. I take half of my b term, so 6 cut in half is 3, and then I square it, so I get a 9. That goes each place. So this red quadratic trinomial, because we completed the square, is now going to factor into x plus 2 quantity squared. That looks promising. And then for the y's, this green trinomial, because I completed the square, it's going to factor into y plus 3 quantity squared. That looks just perfect. And then the last thing I have to do is add up all these little constant pieces. That's what, 16? So now when I say where is the center located, since you're in standard form, remember built-in negatives, so -2, -3 is the center. And the radius is the square root of this last number, so the radius length is 4. Isn't that lovely? Alright, so completing the square, we're just using it twice, and since we're rewriting it in that formula, once we get it in that formula, we can see the center and radius. Same thing here. I'm going to use blue on the x's this time. So x squared plus 18x. I'm going to leave a little blank to complete that square. Plus y squared minus 32y. And then we're going to leave a blank so I can complete that square. And then this original constant of 336 I'm going to subtract over. Get it out of there so I can complete the square in peace. And then those 2 blanks that we just added to the left side of the equation, we're going to have to add to the right side as well. So the blue and the red blank, both of them. Alright, let's figure out what goes inside this blue blank to complete the square here. So the b term cut in half is 9, and then if you square it, you get 81. And then this red quadratic, if I complete the square, let's see, -32 cut in half is -16. Squared is 250. No. 256? I feel like it's 256. I should really check this on a calculator, but let's live dangerously today. Alright, so now that blue trinomial that we completed the square on, it's now going to factor into x plus 9 quantity squared. And then the red trinomial that I completed the square on, this is going to factor into y minus 16 quantity squared. Remember, it's just half of the b term goes in the factor. And then ideally I'd have a calculator because, you know, apparently I can't really add. 256 plus 81, 7, 13, 3. Oh, well, I can do that. That's a 1. Alright, so I promise to give you ones that come out pretty nice, guys, on tests, so don't panic. I'm not going to make you do anything terrible. The center is at -916, and then the square root of 1 is still going to be a 1 for the radius length. It really doesn't get any more complicated than that. In fact, the only thing I could do is have one of the parts of the center at 0, which instead of making your life more complicated, that would give you less work. So that would be less complicated, I suppose. Alright, so let's complete the square here on the x's. X squared minus 28x plus something. We'll come back to that. And then for the y's, so I should put a plus sign in between these terms though, so I don't forget that between the other terms. Y squared minus 32y plus something. And then remember that original constant of 443 we're going to subtract over. so it doesn't mess up my other completings of squares. So whatever that blue number was, it goes here as well. And then same thing with the red number. Keep it balanced. All right, let's complete the square on this blue part here. Ew, 14 squared. 196, right? And then 32 cut in half is 16 squared is 256, we decided. Okay, now that we've completed the squares, these should factor real nice. This becomes x minus 14, quantity squared, plus in the middle. And then for the y's, this becomes y minus 16 squared. And then if I had a calculator, I'd be really happy, but I don't, so I'm just going to have to muddle through this. If I'm going to add these together, let's see, that's a 12, 15, 452, and then I have a negative 443 that I'm adding to it. Alright, 4, 12, 9, 0, okay, 9. I guess I could have done that without showing my borrowing and all that. My bad. Alright, so the center is located at 14, 16. And the radius length is the square root of 9, which is a 3. It's good to know that your math teacher can still do second grade subtraction, right? Alright, so, this one's going to be even easier. Because I will have to complete the square and the x's, but I think that's it. Because the y is just going to be a 0 component. So I'm just going to kind of leave the y alone. If you want to write it as y minus 0 squared, you sure can. I'm going to add that 120 over. And then whatever that red blank is, I'm going to have to add it here as well. So, half of negative 2 is negative 1. Negative 1 squared is 1. So this works out kind of beautifully, because this factors into x minus 1, quantity squared. You can say plus y minus 0 squared, or you can just say 0 squared. And then this is 121. So the center is located at positive 1 comma 0. This is 0, remember. And the radius is the square root of 121, which is 11. Awesome. Oh, this is fun. So not only do you have to go and find the center and radius through completing the square, but then you're going to have to break out some artistic skills and draw a circle. And if you remember what my circles end up looking like, you probably won't feel too bad about your circles because they got to look better than mine. So they have to look better than mine. So let's start with the x's. We're going to complete the square on those. And then we're also going to have to complete the square on the y's this time. They're pretty similar, so that should be nice. And then that 4 that's originally over here, I'm going to move it over to the right side by subtracting it. But I have to remember to keep my balance, so whatever I added in blue has to be added to both sides. Same thing with red. Alright, speaking of the blue blank, half of this is negative 2 squared is 4. Ironically, the red blank is also 4. But the difference comes in when you go to factor. The blue factors into x minus 2 quantity squared because of the built-in negative here. So it's the factor is x minus 2 for half of b. And then for the red factorization, that is y plus 2. Because half of positive 4 is positive 2. And then negative 4 plus 4 plus 4 is 4. So the center is located at positive 2, negative 2. And then the radius length is also 2. That's going to be fun. Alright. Positive 2, negative 2 is the center. And then you go up 2, down 2, right 2, and left 2. And then you totally... Oh boy. It's like it gets worse as time goes on. Ooh, nailed it. So bad. I'm so sorry. Okay, so that's a circle. I'm sure yours looks way better than mine. Drawing of the circle is probably the most challenging part for me. Hopefully you're getting the hang of completing the square here, because what's nice about this is if maybe you didn't understand completing the square from the previous lesson, maybe you get it now. So we've done a whole bunch of problems on it. Alright, same thing with the y's. And then that original constant of 9 we're going to move over by subtracting it. And then remember, those blue and red blanks are being added to both sides of the equation, so make sure they show up twice. So half of negative 6 is negative 3, squared is 9. And then half of positive 6 is 3, 3 squared is also 9. But the factors are going to look different. This is very similar to the last problem where the factors were almost identical, but one is a minus 3 squared, and then the next one is a y plus 3 squared. And then negative 9 plus 9 plus 9 is 9. They're not always going to work out that way. I just had 2 examples in a row where they did. Okay, so let's see if I can make it better this time. 3, negative 3. Radius of 3. Aw, it's like my board is dying on me. It's like it doesn't want me to graph. Don't fail me now, board. Okay. You know, I hate to be a Debbie Downer, but there's no way. So bad. Alright, well that's how you come up with standard form when in general conic form of a circle. So it was a nice little refresher of completing the square, also a nice refresher of using circles in the coordinate plane. Once in a while an SAT, ACT test will throw some of these questions at you. So I'm glad we got the chance to explore a little addition to completing the square.